So this, I'm going to go through a pretty extensive review of volumes, so I actually don't know if you'll be able to get through everything because you guys took a pretty long quiz, but hopefully this video stays under 20 minutes. No homework check today because of the video. I want to make sure I get through everything. So starting off, let's review how to find volumes by cross sections, and then afterwards I'm going to do volumes by revolution. So your cross sections, you could do volume two different ways. We can do a volume as a dx problem, and that would be the integral from your first x value to your last x value, so the beginning of the shape to the end of the shape, and then area of the cross section, so whatever the cross section shape is, say no dash, but oh well, and then dx. And this is where they say that the cross section is perpendicular to the x-axis. And then if you want to do, if you want to do cross sections that are perpendicular to the y-axis, that's when you would use all your y values. In here, your area of your cross section would be in terms of y, meaning y variable should show up in your integrand times dy, and that's when they say the cross section is perpendicular to the y-axis. Okay, so we're going to do a bunch of examples using the same one function. Alright, so these are the two functions. Go ahead and quickly sketch a graph. So that says sine of pi x, and this one is g of x is equal to negative 2x minus 2, and the intersection up here, this point is at negative 1, 0, this point is at negative 1 half, comma, negative 1, and from now on, I'm going to really exaggerate the picture. If I redraw it, I'm going to start off by just using the picture. So the first one I want to do is square cross sections, but I'm actually going to do the question twice. I want to do the question as a dx problem, and then I also want to do it as a dy problem. So starting off, let me just shrink that down. So I have the information here, and I'm going to start off by saying that the cross sections are going to be perpendicular to the x-axis. Okay? So first of all, when you start off, you should have started off with the volume equal to the integral, and this is a dx problem, and the x values are from negative 1 until negative 1 half. Make sure you put the lower limit at the bottom, goes from lower to higher, always for your volumes and areas. So, and then the area formula that we're going to use is side squared, dx. So you just have to figure out what your side is. So over here, perpendicular to the x-axis would be this, and I think it's going to help you guys to draw your shape. This is particularly helpful for circles, so that you can kind of see what the top bottom gives you. In this case, it gives you the actual side. So this one would be the integral from negative 1 to negative 1 half of, and top function is the line, negative 2x minus 2, minus the bottom function, which is the sine of pi x. And I don't really need the parentheses, but I'm going to put them there so that you guys remember that you should focus on putting your parentheses. So that would be, and let me just highlight it one more time, side squared. Okay? So the difference when I start doing perpendicular to the y-axis is, first of all, when I want to do perpendicular to the y-axis, that would be here. It would be a right-left, so here's my square. Here's my right side, here's my left side. And the issue is each of my equations I'd have to solve for x. So this one might be a little bit tricky, but it's the sine inverse of y is equal to pi x. Therefore, we'll call it 1 pi. Actually, let's write it as a full fraction instead of a coefficient. So sine inverse of y over pi is equal to x. And then the other equation would be y plus 2 is equal to negative 2x. Therefore, y plus 2 over negative 2 is equal to x. So this, in this case, when I look at the right and left, the right function is the line. The line is this one, and this is my left function. So if I want to find the volume of the squares perpendicular to the y-axis, I would go from the lower y value, in this case, I'll use purple. In this case, -1, and then higher y value is 0. And then I'm still doing side squared, but I'm going to do right minus left. And then whole thing squared, dy. So what I'm going to do is just give you other shapes to do. And for the first few, I'm going to have you do a dx and a dy problem, perpendicular to x, perpendicular to y. So the next one is equilateral cross sections, equilateral triangular cross sections. And here's the graph again. So in your groups, discuss what the area formula is for equilateral triangle. Hopefully you remember it. Side squared, and I guess I could put the √3/4 in front. Okay? So, perpendicular to the x-axis. So over here again, perpendicular to the x-axis would be this way. An equilateral triangle would look like, kind of like that, I guess. That's your top, and that's your bottom. And let me actually move the top, because I'm going to use that space. Top, bottom. Volume is equal to the integral of my x's. My x's go from -1 to -1/2 of √3/4 times side squared dx. And that's usually an easy way to make sure you're going to get these right. Just write the area formula with a space for your s, and then top function is a line. Bottom function is the sine of pi x. Okay? And then if I ask you to do the dy, so I want a equilateral triangle perpendicular to the y-axis, that would be this way. So this time I'll draw my triangle going up this way. And that would be right, and that would be left. But my y values go from a lowest y of -1 to a highest y of 0, √3/4 side squared dy. And my right side function was the line, which I believe, going back, was y plus 2 over -2 minus my sine inverse of y all over pi. Close that parenthesis. And then the next one I want you to do, isosceles triangles with the hypotenuse in the region R. So that region R piece. And this one, just to save some time, I'm only going to do the dx problem. So region R, but the problem is I want it to be a right triangle, and I want the hypotenuse here. So that's the top, bottom, that's the hypotenuse, this is the right triangle. Problem is, isosceles right triangle, I would want to know how much this base or height, I don't care which one's which. That would be a base and that would be a height. Area of a triangle we usually do by 1/2 base times height, especially if it's a right triangle. Isosceles triangle with the hypotenuse in the region R, because I said the word hypotenuse, it means it has to be an isosceles right triangle. So this one is a little bit tricky. The problem we're having is that the hypotenuse is the top minus bottom, but that's not how we would find our area. So going through, our area would be 1/2 base times height. And the problem is there's two variables, but we only have that one top minus bottom. So over here, I'm going to redraw the triangle. This is the hypotenuse. That's that top minus bottom piece. This is the base. This is the height. Okay? So if I can just rename the base or the height, either one because they're exactly the same, let's call it B and let's call this B because it's an isosceles right triangle. If I can rename that in terms of hypotenuse, then I'll be able to find the area. So what do I mean by that? Remember we talked about this. Easiest way, just do Pythagorean theorem. And we'll call H for hypotenuse this time instead of the H for height. I shouldn't have used H for height, so I'm just going to change that for B. So you get 2b squared is equal to H squared b squared is equal to h squared over 2, and b is equal to the square root of h squared over 2, which gives us h over root 2. So what does that mean? It means that if I know how big the hypotenuse is, then the base is the hypotenuse divided by root 2. You could have also done a 45, 45, 90 triangle to get that same answer. So what that then tells me is if I want to find the volume, I'll do this as a dx problem. X's go from -1 to -1/2. The area of the isosceles right triangle would be 1/2 base squared, because base and height are exactly the same. So 1/2 base squared. The base is equal to the hypotenuse divided by root 2. And that's what makes this problem a little bit harder. The hypotenuse is your top minus bottom. So what does this look like? It looks like -1 to -1/2. 1/2, your hypotenuse is top minus bottom, the top function being the line, bottom function being the sine of pi x, and then all over root 2. Let me do a square bracket, and then squared dx. Looks a little confusing, but the key is the top bottom side is not what you need to find the area. The area is 1/2 base times height, and we rewrote the formula to be 1/2 base squared, and what we want to do is get the base in terms of the hypotenuse. So the base is equal to hypotenuse over root 2. So I just replaced the base squared with the hypotenuse over root 2.